we want to talk about thermal energy. And sometimes you'll hear me say thermal energy, and it may be due to friction, but the way we typically write this is we write thermal like this, or we write ETH like that. So ETH is the shorthand. Let's look at this. So it turns out that this is a more involved topic than the other one. So what is thermal energy? Thermal energy is the increase. Oh, maybe I shouldn't say increase, is the change in kinetic energy of the molecules in a surface. So you got to look at the molecules, okay? You got to look at the molecules in the surface, which you cannot see. But you can feel it. And so what you're going to see here is that a lot of the times we're going to say that thermal energy is the work done by friction. So that's our definition. So the work done by friction is thermal energy. Now, it doesn't necessarily always have to be that way, but in this class, it is. So what do I mean by that? So let's try to draw some pictures here. So what you're going to see here is that you typically have observed this situation. So suppose a block slides across a surface and stops. So typically, the reason why it stops is because of friction, of course. So when I look at this thing, I have a surface. Okay, so when I think about the surface, what actually happens here? I have a block. So when I look at my block, here's my block that I'm actually sliding across. So I push this off and it has some initial speed. But this surface here has friction. So that means friction means that it's a rough surface. So what happens here is that as this block slides and it comes to a rest here, what you're going to find here is that there's two things that happen. There is heating up to the surface that the block is sliding, and then there's heating up of the block. So what you're going to find here is that you're going to get these heat spots. And what you're seeing here is that this here, this is the heating up of the surface. And then this right here is the heating up of the block. So when you see that, that means that there is change in the kinetic energy of the molecules. So when I look at, let's say, heating up of this situation, what this implies here is that there's an increase in molecular motion. There's increase in molecular motion as kinetic energy of molecules. So what's really important about this? Well, what you see here is that energy left the block, and part of this energy goes into, let me move this down one, goes into the surface. So energy left the block because now part of it is in the ground and part of it is in the block. And so what you're going to find here is that thermal energy always leaves the system. And in this case, the system is the block. By the way, before I get too far into this topic, I want to show you an image that I have. And what you're seeing here is that this is an infrared image of a tire rolling. So this is an infrared image of a tire rolling on the street. Ooh, not street, but street. So there's a couple of things that you should know too. So this right here, what does it say here? This tells us the white tells us that it's really hot. So what you're seeing here is that the tire is hot. So that means that the tire surface has increased molecular motion. And then if you look at right here, where it's orange, what you're seeing here is that the road is hot. So that means here that the road's surface has increased in molecular motion. And that's that picture that I'm trying to draw up here. So what we can do here is that we can draw a flow chart of this situation. How do I draw a flow chart? Well, when I look at the work energy theorem, just to follow this process here, so how about if we do, I think that's about all I'm going to be able to do. So this is the flow chart of thermal processes. So the first thing that you see here is that there's work done by friction to stop a car. And then what happens? That work does not disappear, right? In this case, work is transformed into increases in molecular motion. In other words, what we're saying here is that work cannot disappear. Okay, and so what we say here is that now this work, what we find here, this work, or I should say, part of this work is stored in the motion of molecules called thermal energy. And I'm going to take this back and go something like this. One of the key things about the work, this work energy theorem says that if you do work, you change something about the system. So this is the initial system. In this case, it was the car. And then I did work. And I changed the kinetic energy of this car. So what you're finding here is that there's a translation between work and energy. So if I look at the definition of kinetic energy, it's the work stored in moving an object or stopping an object. And then if I go to potential energy, it's what? It's the work stored due to changes in position. And here we specifically refer to potential energy, but there's other potential energies that we will talk about throughout this course. And then we went in and we essentially looked at that, and then we got to thermal energy. So this is the work done by friction to actually change the kinetic energies of the molecules on the surface here. It's the work stored in that. But there's a big difference here between thermal energy and kinetic and potential energy. Not all of the work that was stored stays in the block. And heating or thermal energy is very unique in this sense, because look, if there's friction across the surface, I am heating the block, and I am heating the surface here. So the energy doesn't stay with the block only. It doesn't stay with the car only. And one really clear example is this image here. You could see that the tire gets hot and the road gets hot. So there's a split in the energy. And because there's a split in this energy, what we're going to find here is that when I look at this workflow of thermal processes, I should actually stop right here, because here's where I want to go to the new lecture. I don't want to write too much of the old lecture. I want to stick to what we've done here. So when I look at this flow chart of this thermal process, the work done by friction, right? Work is transformed into the increase in this molecular motion. Part of this work is stored in the motion of the molecules, and that's what we call energy here. So that's what we call thermal energy. So we gotta be careful. So what we're seeing here is we're seeing this thermal energy is stored work by friction, where part goes into the block, or it could be the tire of the car, and the surface it's sliding on. So that means part of the energy leaves the block. Of the stored work leaves the block. As a consequence, what we then say here is that thermal energy always reduces the available energy in a system. And what you find here is that we're going to see something like this here. Okay, so let's look at this thing here. So what we want to do here is that we want to slide a block. Okay, I'm going to slide a block or a box across a rough floor. And when I say rough floor, I really mean that there's some friction. Even though the floor is smooth, there's friction. So I'm going to slide a block across a rough floor where it stops. So let's look at this thing here. So I have my block. Okay, here's my block. And we know that it's going to go across the surface. And what we're seeing here is that we're seeing this type of situation here. So as this thing moves this way, friction always moves in the opposite direction. So this is the force of friction. So then what happens? Eventually this block has to stop. And so we could imagine then that this block is here. And so what we're seeing here is that there's now a trail of heat. In other words, part of the heat is now in the block, right? So part heats up the block, and then part of it is on the surface. But our focus here is the block, not the surface. We want to know what's going to happen to the block. So this is the reason why thermal energy always reduces the available energy, because part of it goes into the surface, part of it goes into the block.